Here's the first problem on fluid dynamics I like to show you. So it says, this problem says, as shown in the diagram, water flows through the pipes, right, as shown in the diagram, and the speed of water at the bottom pipe is 5 meters per second, and the pressure gauge, which measures the pressure, right, in this region of the fluid, reads 75 kilopascals. And based on this information, it's asking what's the pressure gauge reading connected to the top of the pipe, right, upper section of the pipe. That's the question. So we just need to use Bernoulli's equation that we just explained, right, in the previous lecture slide. So let me first write down the Bernoulli's equation. So, and we need to consider two regions. So let's say this is region number 1, and the pressure here is in this region of the fluid is 75 kilopascals, and this is region number 2, and we're going to find out what's the pressure P2, gauge pressure reading P2, right? And let me write down Bernoulli's equation. Says the pressure P1, which is this, plus 1/2 the density of the fluid, and the speed square plus again the density of the fluid, and our fluid system is water, right? Gravity, and y1 is the height, which is 0, is equal to, now this will continue, right? The sum of these three things must be constant. So at section number 2 it becomes P2 plus 1/2 the density of the water, the speed square plus the density of the fluid, gravity, y2, right? So that's just the Bernoulli's equation, right? So, and we're supposed to solve V2. And let's see if we have all the variables to solve this problem. Let's see that. So let's list all the variables. So P1, right, is 75 kPa, right, and it's 75,000 Pascal, right? So kilopascal is 1,000 Pascal. And even if it says gauge pressure, right, you can just keep it in gauge pressure. You don't need to convert into absolute pressure, because if you keep this P1 as gauge pressure, your P2 will be automatically gauge pressure. So don't worry about converting into absolute pressure. Just keep it in gauge pressure reading. So what is your V1? So your V1 is 5 meters per second, right? The speed of water here. And your Y1 is 0. So let's consider this Y1 as your reference line. That's the baseline, right? So what is your P2? I'm just first listing all the variables that we're going to need to solve this problem, right? So P2 is what we're going to solve. V2, do we know V2? We don't, right? What is the speed of the water in this section of the pipe? We don't know. We have to find that out. And what is Y2? Y2 is simply the height, which is 2 meters, right? So the problem is, since we have two unknown variables, right? Two unknown variables, we can't solve this. We can't solve V2 using this Bernoulli's equation. So somehow you have to first figure out V2, and then you can find P2. And how do you find V2? Usually this Bernoulli's equation is used together with another equation called continuity equation of continuity. So this is called continuity equation, and it simply says it's the relationship between the area of cross section of the pipe and the speed. It says A1 V1 is equal to A2 V2. So we're solving V2, right? And this is simply called equation of continuity. That's from the previous topic. V2 is going to be area 1 over area 2 times V1, right? So A is simply the area of cross section, this cross sectional area of the pipe, which is pi r square, right? If it is circular cross section is just the pi r square, area of cross section. And you are given the diameters. See, the diameters of the pipe is 6 centimeter here. Diameter of the pipe here is 4 centimeters. So we convert into radius. So the first diameter is pi. So R1 is half of the diameter, so 3 centimeters. So 0.03 square divided by pi. So the area 2 has a radius of 2 centimeters. So 0.02 square. In terms, V1 is given 5 meters per second. So that's going to give me the V2, right? Which is the velocity of the fluid at section number 2. So that's going to give me, let's see, I don't have the number ready. So times 5. So it's going to give me 11.25 meters per second, right? And that's what, let's list it here. So 11.25 meters per second is the velocity of the fluid water section number. Now we're ready to use the Bernoulli's equation, right? This Bernoulli's equation now we can use, and we're solving for V2. Remember this V2. So now we have to move this equation, right? Move this terms around, rearrange this term, and somehow you have to figure out P2. I'm sorry. We're solving for P2, not V2. I'm sorry. Yeah, it's the gas pressure, pressure reading, gas pressure reading P2. So let's do that. So from Bernoulli's equation, so what I'm going to do is I'm going to move this two terms to the left hand side. It becomes negative. So P2 from Bernoulli's equation, right, is now going to be P1 plus 1/2 the density of the water, V1 square, plus the density of the fluid, gravity, Y1, and minus, right? I'm bringing this to the left hand side. 1/2 the density of the fluid, V2 square, minus the density of the fluid, GY2. That's it. And let's make it a little simpler, because these are common. You can factor that, because 1/2 the density of the fluid is a common factor. We can do V1 minus V2 square, right? And same thing for the potential energy part. So Y1 minus Y2, right? And now you can put all the numbers to get P2. So let's put P1 as P1 is 75,000, 75 kilopascals, 75,000. You must convert kilopascals into pascals, right? So 1/2 the density. This is rho of F is the density of the fluid, and our fluid system is water, right? And fresh water has a density of 1,000. That's from the list of the density that will be given. And what is V1? So let's go back to the list. V1 is, so 5 square minus 11.25 square, and plus the last term is again the density of the water is 1,000, 9.8. So that's the gravity, acceleration due to gravity, G is 9.8. And Y1 minus Y2. Y1 is 0 minus the height Y2 is 2. And now if you do all this, so it's gonna give me, let's see, 8 times 0.2 0 plus 75. Okay, so that's going to give me 4619, and this is, remember, the unit is pascals, right? And you can say this is about 4.6 kilopascals, right, in two significant figures. So this pressure gauge right here attached to the upper section of the pipe will read how much? Will read about 4.6 kilopascals of water pressure.